Okay,
I think we're good now.
All right, awesome. We'll begin. So welcome everyone to the Alberta Lake Management Society 2024 Summer Lake Keepers Training Session. I appreciate everyone taking time out of their lunch period to join in. Please feel free to keep your cameras off if you'd like to enjoy your lunch while the session's happening. I'm seeing some new faces on the attendee list, so thank you for joining today to learn more about lake monitoring and to see if this is something you'd be interested in participating in. For some of you, you've already signed up and committed to joining the program for the summer, so I really hope this will be a good, informative session into what you will be doing this season. And please feel free to ask questions throughout, either just unmute or write them in the chat. I do have my colleague Bradley who will be looking after that. There will also be time at the end for questions as well. And if for some reason we are disconnected, please use the same link to try and get back in. And my name is Kirsten Perrin, and I'm the program coordinator at ALMS. Is there any questions before we begin? Okay. Okay, so just to run through the agenda today, will be a quick introduction to ALMS. What is the LakeKeepers program, going through the summer program design, looking at what the field sheets are, how to do calibrations, looking at the program protocol before you head out, once you get onto your lake, and then after sampling, looking at shipping logistics and next steps. So who is ALMS? So we are a nonprofit organization that's been around since 1991. We are located in Edmonton, Alberta, with a mission of building awareness and understanding of lakes by engaging individuals and communities in monitoring, management, and education. We receive funding from various stakeholders to conduct extensive lake and recreational beach monitoring within Alberta to build baseline and long-term databases for many of these lakes. We work very closely with many volunteers and communities on different lakes, as well as work alongside watershed planning, advisory committees, lake stewardship groups, industry, universities, and government. Other aspects of ALMS includes education through seminars, conferences, and events, synthesizing the data into reports, providing scholarships for aquatic research, participating in local, provincial, and national programs, and offering expertise to organizations concerned about their lakes. So our core team is pretty small. We have Bradley Peter, our executive director, on the call with us today. We also have Brittany Onesic, our program manager, and we have Kirsten Latender, our program technician. And we've also just welcomed our new seasonal staff that'll be joining us for the summer and supporting our program. So we're very excited to have them with us. So what is the LakeKeepers program? So this is a citizen science program that consists of the winter and the summer LakeKeepers. The winter LakeKeepers was piloted in the winter of 2018 to 2019, while the summer program began, I believe, in 2019. Both sides provide volunteers with the tools to independently monitor lakes or reservoirs for parameters that are important to understanding lake ecology and health, both in the summer and the winter. And there was the focus on engaging anglers and lake stewards initially to participate in collecting data and helping to connect fisheries with the water quality. So these programs engage with volunteers year-round, provides a flexible monitoring plan to accommodate different schedules. And typically what is collected within these programs is temperature, dissolved oxygen, more recently added is connectivity, as well as a variety of water nutrients, chemistry, and environmental observations. So these monitoring programs address a variety of environmental concerns, such as climate change, salinization impacts, fish habitat, connectivity, variations between summer and winter water quality conditions, algae ecology, and groundwater dynamics. So through regular monitoring, this allows us to track temperature trends, precipitation patterns, and connectivity levels to help understand the impact on water quality and the aquatic ecosystems. By evaluating the habitat suitability for fish through dissolved oxygen readings and nutrient levels, or detecting seasonal variations, assessing the algae growth risks, and studying the groundwater interactions, this can help us make informed decisions to protect and preserve our lakes and to try to understand these observed changes. So Summer Lake Keepers, the program helps to provide another avenue for citizens to collect data, typically on a smaller, maybe more remote lakes in some cases, and this helps fill in the lake monitoring gaps within Alberta. So many of the popular recreational lakes are typically heavy sampled and they have a lot of historical data on them, but this program allows for those lakes that may slip through the cracks, may have a more pointed interest with certain citizens, and this can help to build a baseline of data and track the changes over time. So just to go over our summer program design. So as I mentioned that we measure temperature, dissolved oxygen, and connectivity. This is done using our YSI Pro Solo probes. And then we also have materials such as our sampling instruction manual, our field sheets, our bottle sets, our calibration solution, our chlorophyll A filtering kit, and our set key disc, which you can see on the top right picture. All these materials will be provided to you and either shipped to you or be available for pickup, depending where you live near our office. And the design is for this summer, we are asking our volunteers to please prioritize one lake to sample at. And this will consist of 3 monthly sampling trips. So wherever you can fit those 3 monthly trips between June and September, the scheduling is pretty flexible. We just ask that you please let us know when you plan to go out and when you plan to ship samples back. And then there is a reporting component as well. So we do compile an ALMS report, and the data does get uploaded to the Gordon Foundation's data stream platform that is publicly available. So just a quick look at the equipment list. So this is all the things that will be sent to you, including the manual and field sheets, a tape and weight to measure bottom depth, your Secchi disc, the YSI probe, nitrile gloves, coolers with ice packs, and then you'll have your bottle set, which will include a chlorophyll A bottle, a clear bottle for total phosphorus, and a clear bottle for microcystin collection. And then we also have our chlorophyll A filtering kit, which provides all the tools you'll need to do the filtering, which I will run through those steps later on in the presentation. So it's just important that once you receive your equipment, please just review this equipment list in the manual and let us know if anything is missing. Okay, so this is what the front of the field sheet's going to look like. It's got a variety of information on it. So at the top here, we have our lake name. We have our location name. That's kind of just a reference point on the lake that we will match the GPS points that you give to us. For example, Pigeon Lake, if you go out and sample near the provincial park, or if you're at Wabamun Lake and you're close to Seba Beach, that's something you can just write on there. If there's a village, campground, or park or bridge nearby, you can also include that, and that just gives us that reference. And then we have the date, the time sampled that day. So this time can also be written onto your bottle set. And then volunteer names and hours spent sampling, and that'll include your calibration, your transportation, your sampling, and your filtering time. So we encourage our volunteers to please record that. We just like to know how many dedicated hours you're putting into our programs. We appreciate it. And we have our kit number, which is just going to be a sticker on the top of the probe kit. So if you could just record that, that'd be great. Okay, and then down below we have our environmental observations. So air temperature and wind speed and direction. Cloud cover estimate as a percent. So it's basically just looking at the lake as a whole in the sky. Just an estimate of how much cloud cover there is. Might be none, might be 50%, it might be a completely overcast day, and you could just write 100% or anything in between. This just gives us an idea of like what the day looks like. And we have our 24-hour rainfall. So this can also be found on a weather app or a weather site as well. And this just helps us to understand how much rain might affect the water clarity. And given if we have storms this summer, then that's important to know as well. And then we have evidence of cyanobacterial blooms. So I provided a few pictures of what blooms may look like. This is just to observe the level of blue-green algae present on the lake. And these blooms can appear in different ways. So oftentimes what we see is green particles in the water. When we look down from the boat, there's no distinct clumps. Sometimes the blooms can appear more like paint streaks, and other times as scums that float on the surface. Some blooms can even appear brown or red in color, but often will be kind of that bluish green color, and they could also be foamy or in mats. So just describe what you see as best as possible. And there is that other option as well if you want to record something different. And then there is the section referring to our Secchi depth, which I will go into more detail later on. And of course, we have our GPS coordinates. This is very important to record once you get to your site. We want to know where the samples were taken from. Okay, and then just at the bottom here, we have our probe calibration section, and that's to record our barometer reading for dissolved oxygen and the calibration connectivity solution, which will be sent with the supplies and be clearly labeled, and I will go through calibration steps in a bit. Okay, so then this is the back side of your sheet. So in your kit will be that tape and weight, which is used to find your bottom depth. So here's where you can record it. So this is an important note that all of our probe cables will be pre-marked, and they will be pre-marked in meters. And I know a lot of us like to use feet, including myself. But for our program and database, we actually work in meters. So when measuring your bottom depth, please measure in meters, which is available already on the tape and weight. And this makes it really easy once you start doing your profile measurements to know when you're at the bottom. We've had bottom depths marked in feet, but then they'll technically exceed the profile measurements because it's marked in meters. So then the data doesn't really match and make sense. So just please remember that the probe is already marked in meters, and we will record bottom depth in meters. And there will be a marking guide in the manual as well to indicate what depth the colored tape will indicate. So here is a large table to indicate your probe measurements. So this is where you will record your temperature, dissolved oxygen, and the connectivity, which, as I mentioned, is a new component. And I'll go over that in more detail soon. So you'll start at your 0.1 meter and record all these values down to the bottom depth that you measured beforehand and in meters. And there is a spot for to record your chlorophyll filter volumes once sampling is done. I will go over filtering protocol in a bit, but there is a new addition to the side, which is the color of the filter. So once you've filtered your first paper, before you add your preservative, you will record what color the filter paper looks like in this space. And then there's also an additional comment space, just if there's any difficulty accessing the lake, any changes around or in the lake, that's where you can record. And sorry. And then we have our checklist at the bottom, so please just refer to this just to make sure all the steps have been taken during your sampling trip. Okay, so let's talk about before you head out. So you want to make sure your probe is charged. These probes do hold a charge quite well, so likely they'll be okay, but just make sure you check it. The charging cord will be provided in the kit. You're going to calibrate dissolved oxygen and connectivity. You're going to complete your online informed consent, which is on our ALMS website on the Summer LakeKeepers page. Please check the weather to ensure conditions will be safe on the boat throughout the entire trip. Again, sometimes weather can surprise you and roll in quickly, but it's good to know beforehand if something might occur. Make sure you have a cold ice pack to bring out with the bottle set in the cooler. While you're checking the weather, you can find the 24-hour rainfall accumulation for the area and mark this on your field sheet. And again, this just helps to understand the impact of rain on the water clarity. So just a quick note about GPS coordinates. Please record them on the front side of your field sheet. This is important for us to know where on the lake you've collected your bottles and samples from. So these GPS points can be collected with a Garmin or any GPS device, such as your phone or tablet. I myself often just use like a free app on my phone. So the important thing is to record these values as you see them on the screen and to record as many digits as shown. So there are different types of formats and neither one is wrong. It just has to be recorded correctly so that we can just pop it into Google Maps and be able to find the right spot. Okay. So we'll talk about the probe calibration. So calibrating can be done at home if you don't live too far from the lake, but we do highly recommend that it gets done at the lake. It can be done out of the back of your vehicle or at a picnic table, just on a stable surface is preferred. Calibrating will be done for both dissolved oxygen and the connectivity, so we'll run through these steps right away. And all of this will be provided in the manual as well. So important thing to note is just to make sure you have all your calibration solution and a graduated cylinder with you. Just bring that to the lake to be able to do this. So the first thing you'll do is calibrate your dissolved oxygen. So this is just a picture of what our probe looks like. We have that gray sleeve on the side, we have the guard in the middle, and then our actual probe. So all this can be disassembled. You're going to remove the gray sleeve and the guard. You're going to take the Kim wipe tissues provided in your kit and gently dry the surface tip of the probe. There will be a little yellow sponge in the gray sleeve. Make sure that's moist. It does not have to be soaked, just slightly wet. And then you're going to put the metal guard and the gray sleeve back on, and you can let that sit in your kit for 5 minutes to calibrate. And so this is our handheld, which you're going to attach to your probe. So there'll be a cord, attach it, you're going to turn it on. You're going to press the cal button at the bottom. You're going to choose the ODO option, the first one. Choose DO %. And it's going to bring you to this screen. So this is where your barometer reading will be. And you can record this onto the front side of your field sheet. And you're going to wait about 1 minute. And if you can see the little black box at the bottom of the screen, there's 2 lines. We want to make sure those lines look stable, that there's no crazy peaks occurring. Otherwise, something maybe just need to be fixed, or there might be a scratch on the surface of the probe tip. So just let us know if something's not calibrating correctly. So once everything looks okay, you're just gonna choose accept calibration. And then you can press escape and it'll take you back to that home screen. And you should see your temperature, dissolved oxygen, and connectivity. And this is an old picture, so it will have the connectivity on it now when it arrives to you. Okay, and then next is your connectivity. So for those who have already done the program with us before, this is new. Our probes can now measure connectivity, which is the ability of water to conduct an electrical current. And we want to measure it to provide insights into the lake's dissolved ion content, which is crucial for understanding water quality, salinity, and nutrient levels. And this helps us assess the potential impacts on the aquatic life. So I'll just run through right now how to calibrate this. It can be done right after you finish the DO. So keeping your cord attached to the handheld, remove the gray sleeve first, and then you're going to pour the connectivity calibration solution, which will be provided just in the bottom left. That's kind of what it'll look like. So you can pour this maybe like halfway into your graduated cylinder. And then what you want to do is stick your probe with the metal guard on into your graduated cylinder. And then you're just going to top up with the solution. You just want that's where the sensor is, just at the top there. So we want that covered in the solution. Also noted on the bottle is a number. So for this example, it says 987. That's you're going to record onto your field sheet here. So once the probe is inside the graduated cylinder and it's filled up, we're just going to let it sit for a few minutes again. Okay, and then we're going to go back to our handheld. We're going to press calibration. We're going to choose connectivity this time. First one, specific conductance. And it's going to take you back to this screen. So we actually have to make a change. So on the calibration value, that value that was on your bottle, the 987, for example, this value will change. So just always record what's on the bottle. We're going to go into the calibration value and just change it to whatever matches on the bottle. And we're going to wait a minute again to make sure everything's stable. Once everything looks okay, accept calibration. And then you can press escape back to the home screen, put the gray sleeve back on, and your probe is ready to go. Okay, so now we'll talk about going to your site. So your probe's all calibrated, you have your barometer and connectivity solution values written on your field sheet. You have the field sheet with you, your manual, and a bottle set in a cooler with a cold ice pack ready to go. Please always remember an ice pack as it's summer and we don't want our samples heating up too much. So now the next step is you want to make sure your boat is prepped and that you have some safety gear with you. Make sure your boat has enough gas and oil to go out onto the lake for an hour or two. Or in the case of canoes, that the paddles are in good shape. Having an emergency paddle on a motorized boat is always highly recommended, just in case something does go wrong and you need to make it back to shore. Bringing a life jacket or PFD onto your vessel is required by law. However, it's your choice to wear it while on the boat, but one for each person must be present while you're out on the lake. A very important item that is needed is an anchor or sufficient weight, depending on the size of your vessel, along with an attached rope that is of appropriate length for the lake you are sampling. So just a rule of thumb we have is for the rope to be twice as long as the maximum depth of your lake. I know in some cases we are unaware of the depth of the lakes, maybe because they've never been sampled before. So likely having a 20 to 30 meter rope will be good. But if you know that your lake is more shallow, maybe only a 10-meter length will be needed. Either way, this is important to have while you're reaching your sample site to help prevent your vessel from drifting while you take the profile measurements and collect all your bottles, because you will be sitting there for an extended period. It's important that someone has a working cell phone or radio with them, especially if service is not great in that area. It's also good to just have a cell phone. This can to collect your weather data, like your temperature, wind direction, and speed, and also your GPS coordinates. Other safety gear to consider would be a buoyant rope for rescue purposes. GPS, this can be used out of, or like a Garmin could be used out of service, and a whistle or air horn to signal an emergency. A few other things not listed would be a small first aid kit, boat repair kit, flashlight, all optional, but just important to consider. So once your boat is equipped and launched, you're going to head out to where you want to sample. The location on the lake is your choice. Once you arrive, drop your anchor, turn off your boat. We don't want the gas contaminating your samples, and secure it, or drop the anchor to secure it, and then grab your GPS coordinates and record them on the field sheet. And please do not sample in strong winds. Not only is this a safety concern, but also a sample integrity concern, because if the probe is drifting a lot while being lowered down, then the data you're getting is not like that vertical profile, and it just won't accurately reflect the depths. So depending on the size of your lake, the wind speed will be very important. It's just something to consider while you're out or before you go out. So during sampling, so now that you're at your site, you're going to record all your measurements on the front side of your field sheet, including all that sampling information, the environmental observations. You're going to use the tape and weight to measure bottom depth, and record your profile measurements on the backside of your field sheet. This is also a good opportunity to fill out any additional comments you have, vegetation types you see, weather, wildlife, how busy the lake is, if there was any difficulty launching your boat. And this is a big difference between the winter and the summer sampling. In summer, we measure the Secchi depth, which relates to water quality or transparency. So I'll just go over the steps right now to measure. So first and foremost, very important to measure your Secchi depth on the shady side of the boat, and to remove your sunglasses. So this will minimize the reflection off the water. So wherever the sun is in the sky, just head to the opposite side of your boat. Sometimes the sun may be directly above you and there really isn't a shady side. So just do your best to choose what side you think will interfere the least when measuring. Next, you're going to lower your Secchi disc. So that'll be your black and white disc. And you're going to put it into the water and just take a minute to look at the color that is reflected on the white part. So on your field sheet, that's where you can record the color of the Secchi disc. So it might look green, brown, might not have any color. And there is a box for other as well if it looks like a different color. And then you're going to slowly continue lowering your disc until the white stripes just disappear from your view. So make sure to become familiar with the marking guide so you can keep track of the length being lowered, and this marking guide will be in your manual. Once the disc just disappears, hold it there, record that depth on the field sheet under the disappears line. The chain is already also marked in meters. So next step is to slowly raise the disc until you just see the white stripes again. And then you can record this depth on your field sheet on the reappears line. And then you can wrap up the Secchi disc all the way back up and then calculate the average of those two depths and record this depth as your Secchi. So just for example, if your Secchi disappeared at 2.7 meters and became visible at 2.1 meters, then the average would be 2.4 meters, and that's your Secchi depth.
I have Kirsten frozen on my screen. Is she frozen for anyone else?
So your temperature, dissolved oxygen, and connectivity. So you will start at the first blue tape marking, which is 0.1 meters. You're going to record all the readings for your temperature, DO, and connectivity as they read on your handheld. So just please allow a minute for the probe to acclimate once in the water. Then you can lower it to your next marking of 1/2 meter, record all 3 of your measurements, and then continue to do this every meter until you reach your bottom. So if you measured your bottom depth, let's say 5 meters, you can take your last measurement at 4 meters. Just to avoid the probe going into the sediment, because then it's just going to skew your reading. So just aim to stop a meter above your bottom depth. Okay, and the last step while you're on the lake will just be to fill all your bottles provided. So it's pretty much the same collection steps, but just a few key points to point out is please label all your bottles before you start dipping them into the lake. It's a lot more difficult to write on the labels with a Sharpie once the bottles are wet. The labels will already be on the bottles. It'll have lake name, location, date, and time. Please fill those out. For the start time, this can just match that time that you first recorded when you got to your lake site and that you recorded on the front side of your field sheet. And then please triple rinse all your bottles in the lake before filling them up. The 2 bottles to pay attention to are the microcystin bottle. Just leave a little headspace so that it doesn't explode when it gets put in the freezer. So just fill like 3/4 full. If you can fill it up to the top and then just dump a little out too, that makes it easier. And then you'll have your G2 preserved bottle, and this one will require you to add the preservative again. So please put on your nitrile gloves that are provided in the kit when adding the preservative, as this is a small amount of sulfuric acid, so we just want to be safe. So when you add it in, just invert the bottle a couple of times. All these bottles will go back into your cooler with the cold ice pack while on the boat until you get back, and then I'll talk about bottle storage here right away. So these are the sampling steps before you get on the lake and while you're on the lake. Is there any questions?
There was a question about whether you'll be providing the slides to folks afterwards.
Yep, just like not quite as the presentation itself, just the individual slides. Is that?
Yeah, probably just a
do
copy
that.
of the presentation posted would
Yeah.
be, yeah.
Okay, yeah, I will be sending out a link to the recording after today, and then you can also access this presentation on the ALMS website on the Summer LakeKeepers page once I get that up.
Great. And then there was a question about where can lake data be found, and I've responded to that in the chat. So if anyone wants to take a look at the chat, you can see a few options there. Those are the only chat questions. So if anyone has questions they want to unmute for, you can go ahead and do that.
Perfect, and there will be time at the end for questions as well. Okay, so we'll talk about after sampling. This chart doesn't quite reflect the Summer LakeKeepers exactly. Not all the bottles on here will be collected for Summer LakeKeepers. But the ones that we will have are the G2 preserved, the microcystin, and the chlorophyll A. So with the hold time, with the G2 preserved, because we add that, it does increase the hold time to, and Brad, maybe remind me how long we get for that one.
For microcystin frozen?
No, for the G2 preserved. Is it 2 weeks?
Yeah, that's a great question. I will confirm for you before the end of the presentation, but I don't recall off the top of my head.
Okay, yeah, no
I'll find
problem.
out for you.
Yeah, no problem. It does extend, like with some of our bottles, you only get a 3-day hold time. It does extend past that, which is nice. The microcystins will get put into the freezer after returning from the sample site. So just be sure to do that. but with the G2 preserved, this can just get put in the fridge. Please don't freeze it. And then the chlorophyll A must be filtered within 24 hours of the collection time. So if you get back from your trip and you're like, I don't quite have another hour to spare right now, that brown bottle can go in the fridge to keep cold. Just make sure that it does get filtered within that 24 hours. And then after filtering, you're gonna have 3 filter papers in a Ziploc bag, and these can go in the freezer with your microcystin bottle. And then we'll just confirm that whole time for the G2 preserved, but we do still highly recommend that you ship the samples or drop the samples back off to the ALMS office within a couple days of sampling. This just allows us more time to process them and for the labs to analyze them well within the hold times. So please just let us know once you've sampled, when your samples are ready, and we can discuss a shipment date and just plan to ship back within a few days after you're done your sampling. Okay, so for the chlorophyll filtering, so this will be for your brown bottle. I'm just going to go through all the steps here. So these are your pieces. So you have your hand pump, you have your filter apparatus, you have the wash bottle, your graduated cylinder, and you have your little filter paper here. So your first step is to unscrew that filter top. We've kind of have 2 different systems. This is the one we're trying to use the most now, but sometimes we might just have that funnel and a rubber stopper, and that just goes in, and you're going to see that same top piece. So it's just the bottom will be different, but you can still attach your hand pump with the vacuum tube to your filter apparatus, and it'll still operate the same. You're going to place your filter paper on that filter bottom, like in the picture on the bottom left or right, sorry, and then you're going to screw the top back on, and then you're ready to begin filtering. Okay, so these are all excerpts from the manual. So this won't be the last time you see this, but a big difference between the winter and summer sampling is the likelihood that you will have to filter less water in the summer to get color on it, as a lot of lakes will produce more algae as the season passes, whereas in the winter, the water is typically more clear. So the goal of this is to just get a bit of color on your filter paper, not to have it saturated with it. So please note that the brown chlorophyll A bottle is a 1 liter volume, and we need 3 filter papers from this volume. Therefore, we ask that you filter maximum 300 milliliters per filter paper, so that we have enough water to create a successful triplicate. So for some high nutrient lakes, you may only filter 20 to 50 milliliters, and you will already see some color, whereas some lower nutrient lakes may require a full 300 milliliter filtration per paper. Sometimes you may filter more at the beginning of the season, and then you'll have to filter less as the season goes on, and this may be because algae production is increasing. All these scenarios are normal and okay. It's just about determining the right filter amount for your lake. Okay, so you're going to fill your wash bottle with the pure water provided. You can just fill it like a third full. This is going to be used to help clean your apparatus. So you're going to start by wetting the filter paper a little bit with the pure water, and then using the hand pump to gently increase the pressure and let the water filter down. You're going to take your chlorophyll bottle and invert it a few times just to mix the water evenly, and then you could start at 50 milliliters for the summer sampling just to start, pour that in and filter it down with the pump. So you're going to look for a slight green color change, or any color really. It might not be green. If you don't notice a color change on the filter paper, you can measure another 50 milliliters. If it's difficult to see if there's a color change, you can unscrew the top and then just compare the white edge to the middle. If there's a bit of color, then you can stop there. Otherwise, you continue filtering 50 milliliters at a time until you reach a max filter volume of 300 milliliters. If you filter your first 50 milliliters and you find that your filter paper is already oversaturated in color, get a fresh filter paper and pour less. Maybe you could try 20 milliliters to start and go from there. It's just important to keep track of your filter volumes as you add more, as this will be recorded at the end, and we just want that that final filter volume to match. So once you have your sample filtered, you're going to use your wash bottle with the pure water inside to triple rinse your graduated cylinder and also the inside of your filter apparatus. You can just pump that water down, and then you're going to add your preservative. So it's going to be 3 drops of the magnesium carbonate onto the filter paper. And then you're going to record your filter volume on the back side of your field sheet. And here's also where you can note the color of your first filter paper and record this on the field sheet. Your sample will then be ready to go into your Petri dish. So unscrew the top part and use the tweezers provided to carefully lift the filter paper by the edge. Be careful not to touch the inside where the chlorophyll sample is in the middle, and then put it into your Petri dish. Fold the paper in half twice, then put it into your Petri dish. Okay, and then there's going to be labels provided. So please record the lake name, location, the filter date, time, and the filter volume on your labels. This is a very important step so that the labs know how much was filtered on each paper. So, and then either using the tape provided or the label itself, secure the Petri dish shut along the edge and wrap the Petri dish up with aluminum foil. This just prevents light messing with the sample integrity.
Kristen, there's a question about the color of the final filter. The question is actually, can we share a photo of what a filter looks like? And definitely we can do that, but do you want to provide any more details on what color you're looking for?
Yeah, for sure. And I can definitely add some example pictures into the manual for this summer as well. But typically it's going to be a green to brown kind of color. We've seen pink, we've seen reds before. That's not common. There might be other organisms inside. So usually it's going to be a slight green to brown for summer.
And basically if you can see the green and the brown, then definitely the laboratory equipment will be able to detect that. And we don't need a lot, so a hint is usually what we're looking for. So if you think there's a hint of green, a hint of brown, then probably that's enough for the lab to detect that.
Yeah, exactly. And again, that might only take 20 milliliters, 50 milliliters, all the way up to, again, max 300 milliliters. There might not be any color at all, and you've now filtered 300 milliliters. That's okay. You can stop there. And then you can move on to your next filter paper. So that's your first filter paper, and then we're actually going to repeat all that twice more. Because you want a total of 3 filter papers. So the nice thing is once you get your first filter volume, you can actually just match that now to your next 2. So if you filtered 150 milliliters on your first filter paper, now you can just automatically pour 150 milliliters into your graduated cylinder for your next 2. And you're just going to exactly repeat all the steps as is, preserve at the end, label your Petri dish, and wrap it in aluminum foil. And then all 3 of them can go into a Ziploc bag, and these can go into the freezer until you're ready to ship back or drop off samples to us.
Sorry.
I was going to ask, is there any questions on the filtering?
Yeah, there was just a follow-up that makes a good point, which is that sometimes the filter paper is not colored, but you can just see particles, like green particles or brown particles on top of the filter paper, and that's totally acceptable too.
Yeah, exactly. Any other questions? Okay, so for the shipping, on the right, there's just a copy of the shipping slip that's going to be sent out with each of the kits this summer. So this will have our Purelator account number on there and can be used to ship the samples back. You don't have to ship this slip back with the samples, just keep it with your sampling kit. Either for this season if you are holding on to a kit, or it can get dropped back off with everything once you get back to the office. And please always choose express or overnight shipping so that our samples can get to the office as fast as possible. In the summer, it's important that 1 or 2 ice packs, cold ice packs are included with your cooler, just to prevent the samples from getting warm. And yeah, again, just having, just planning to ship the samples back as soon as you can, or drop them off to our office as soon as you can. You can contact us at lakekeepers.alms.ca, just to let us know, and then we'll anticipate any samples arriving. Another important thing is to please send a copy of the field sheets with the samples, or they can be emailed to the lakekeepers@alms.ca. We need that field sheet just to fill out our data, to give information to the lab. So we just need a copy. You're welcome to keep the original. And to please email or text a picture of the tracking number for Purelator as well. Again, just so we can keep an eye on things if delays happen. Okay, so just some considerations for summer. Please avoid shipping samples back to the office on Fridays, as ALMS is not open on the weekends. We recommend at least leaving 2 weeks between each sampling trip, and noting that weather can be a much bigger hindrance in the summer. So just to consider backup dates. And not just storms, we are already entering wildfire season, so that's going to be a big consideration. If it's too smoky out, please don't go out. We don't want anyone risking their health over this. We can find an alternative date. Just keep in touch with us if plans change. Just note our office closures. We are closed July 1st, August 5th, September 2nd, and September 30th. And again, we ask our volunteers to just prioritize one lake this summer that can be accessible by boat or canoe. And consider that your boat is able to fit the probe kit, the sampling gear, and the bottle set. And we also really encourage our volunteers to take photos while they're out, whether that's of the lake, the shore, algae blooms. If you do see an algae bloom, please do take a picture of that and send it to us. But also of volunteers while you're out, you can take pictures of each other or anything interesting you see, and we always appreciate getting these photos. And you can email them to the lakekeepers@alms.ca email. Okay, so next steps. So there are limited spots left. I have discussed with some of you, we are confirmed. If you're not sure, feel free to either write in the chat right now, or you can email at lakekeepers@alms.ca. If you are interested in joining, yeah, please email me, let us know which lake you are interested in doing. We'll let you know if there's still some openings, but yeah, we encourage anyone interested. It's a good program to do for the summer. It's flexible, it's fun to get outside. And if you are going to be participating, then we ask our volunteers to please go onto our website, onto the Summer Lake Keepers page. There's an informed volunteer consent form that needs to be filled out before you go out. And yeah, we'll be following up shortly to coordinate shipping plans for the gear and equipment. So just keep an eye on your email for that. And then the sampling can begin in June once you've received your equipment. Is anything? I think that's good. Okay, so I'd like to thank all our communities, our volunteers, our staff, our board for all their ongoing support, and also a big special thanks to our funders, the Alberta Conservation Association and the Cabela's and Pro Bass Shop Outdoor Fund, in which we get to continue monitoring with all of you this year for Summer Lake Keepers. So thank you for that. And my information is just on the side there. Feel free to contact me for more information or to ask about joining. For those already confirmed participating, we'll be reaching out to you in the next few weeks here through this email, so just keep an eye out for that. And we can discuss the start times and the shipping. And with that, I hope this presentation was informative and provided insights into some of the work we do at ALMS, and I will happily take any questions now. Thank you.
Thanks, Kirsten. That was great. I will stop the recording and then we can take questions. The only other comment in the chat was that Jim and Margot plan to continue sampling Sturgeon Lake. So thanks to both of you for doing that.
Yeah, and I do have you confirmed. So that's awesome. We'll be reaching